Array is an important concept in computer programming, and array is a data structure that is most often used to build complex or composite data structures like stacks and queues. So in this lesson we will talk about arrays, and we will see using some programming constructs what all different operations we can perform using arrays and how arrays are stored in computer's memory. We define an array as a collection or a systematic arrangement of objects of the same data type. And a typical definition or declaration of an array would look something like this. So an array definition will have a data type. In this case, we have an array of integers, and then we will have the variable name, and we will also have the size of the array. Now, where does this concept of array fit in programming? Let's say in a program we want to store the marks of 50 students in a class in, let's say, mathematics. Now in our program, to store these values, we can declare 50 different integer variables like s1, s2, s3 all the way till s50. So we kind of declare 50 different variable names corresponding to these 50 students. Now let's say we want to calculate the average marks of all the students. So to calculate that, we will have something like a total of all the marks. So we'll have a variable total, and then this total will be equal to s1 plus s2 plus s3 and all the way till s50, and average would be total divided by 50. But what if we had 500 students or even more? It would be very unmanageable to declare 500 different variables and use them in our statements. So in these cases we declare an array. So let's say we declare an array S with a size 50, and this array is an array of integers. Now in this case also I have 50 different variables, and I access them as S0, S1, S2 and so on. We start at index 0 and we go all the way till index 49. And our program will be something like, we again have a variable total, and this time we run a loop from 0 to 49, and we use the variable I as index and keep on adding si to total, and finally we return or calculate average as before, which is total upon 50. This was an array of integers. We can also have an array of float or an array of character or an array of a user defined class or structure. And this was a simple one-dimensional array. We can also have arrays of 2-dimension or 3-dimension. Let us now see how arrays are stored in computer's memory. Okay, so let's say this figure in the left here is computer's memory, which is divided into these segments or partition, and each segment is 1 byte of memory. In fact, we are only showing a part of the memory in the form of these segments or partitions, and that's why it is extending towards the bottom and the top, because in reality the memory will have many more bytes. In fact, computer's memory is a very large array of bytes. Now in computer's architecture, each byte of the memory has an address. Let us assume that here the bottommost byte, which will be somewhere deep down here, has address 0, and as we go on towards the top we keep on increasing the address like 1, 2 and so on. So let's say, for example, if this particular byte has an address 100, then this particular byte will have an address 101, and we will go on like 102, 103 and so on. And as we know, in C or C++ we can also have pointer variables that can store the address of another variable. Now when we define an array, something like an integer array, let's say for example of size 4, then if an integer typically takes 4 bytes of memory, then an array of 4 integers will take 16 bytes of memory. When the program executes, the computer allocates 16 contiguous bytes in the memory for this array A. So the computer kind of allocates 4 contiguous blocks of 4 bytes each. The first block or the first 4 bytes will correspond to A0, and the next 4 bytes or the next block will correspond to A1, and similarly we will have A2 and A3 as well. Now access to an element in the array or its modification, all of these operations take constant amount of time, and it is not a function of the size of the array. Or in other words, we can say that the time complexity for accessing or modifying an element in the array is big O of 1. Now how does this really happen? Let's try to understand. When we declare an array, like say for example here we have declared an integer array of size 4, then this variable a is nothing but pointer to the first element in the array, and we can also say that this variable a is a pointer that points to the base address of the array, and this is better explained in a real program. So let us go to a compiler and write some code. So I will write a simple C program here. What I will do is I will declare an array a of size 4, an integer array, and as I had told you earlier, a is nothing but a pointer to the first element in the array. So if we try to print a, and I have written a simple printf statement, which is the statement to print a variable on the console, then this should give me the base address or the address of the first element in the array. Let's now run this program, and we get an output which is equal to 2947240, and this should be the address of the first element. But how do we know that this is the address of the first element? Well, we can print the value at this particular address, and as we know, to print the value at an address a pointer variable points to, we need to put a star in front of the pointer variable in C or C++. So star a should give us the value at the base address or the value of the first element in the array. So star a is same as a0, and let us now see what we get. Okay, so we got an address in the first line, and this address is different from the previous address because every time the program runs afresh, the memory allocation will be different, and the value that we are getting is some garbage value. This is happening because we have not yet initialized or filled any data in the array. So what I'll do here is I'll fill some data. Let's say a0 is 1, a1 is 3, a2 is 4, and a3 is 5. And now if we run this again, the first line once again gives us the address of the first element, and the second line gives us the value of the first element, and that's correct. Now I'll do something else here. I'll print a plus 1, and if we know the basics of pointer arithmetics, then because a is a pointer to an integer, then a plus 1 should increment the address by 4 bytes, which is the size of the integer, and take us to the next integer. So a plus 1 should give us address of the second element in the array, and whether this address is correct or not is something that we can verify by looking at the value at this particular address. And if I'm alright, then this should be star of a plus 1 should be a1 or the second element in the array. Let us now run this. Okay, so first line is the address of the first element, and as we can see, the second address, which is the address of the second element, is 4 more than the address of the first element, and we have got the values right. a0 is 1 and a1 is 3. So now it should be evident why accessing or modifying an element in array takes constant time. When we try to access an element in the array, the computer first calculates the address of this particular element using base address and offset. So for example, if we want to access the fourth element in the array, which is a3, then the address is calculated from the base address a by adding the offset 3, and the value at this particular location will give us a3. All these pointer arithmetics that we are doing here are possible only in C and C++, and if you are using a language like Java, you do not have explicit pointer variables, but still the internal working of how things happen in memory will be pretty similar. So this was some of the basics about arrays and how they are stored in memory and how they are interpreted in a computer's program. In the coming lessons, we will talk more about arrays and solve a couple of problems. So thanks for watching.